So here we go. So has anybody ever seen one of these? Do you know what this is? So this is an FRP tank. This is what they call a cable wrap tank. So this is an FRP liner, what you see here. These are steel cables, and they're wrapped around the tank. And you can see this is a process vessel. This is still in service, by the way. So this is a technology that probably came out in probably the 70s, maybe, and it's still out there today. They patch up the liner on the inside and they keep going. So what's the integrity of that, and what's what's the reliability that you need to be taking a close look at if you got something like that. So here's an overview. So we're going to talk about what are the owner's priorities, some of the unique challenges related to non-metallics. Why do we need to have a maintenance assessment program? We bought good equipment. We know the fabricators. It's working fine. Why do I need to do that? And we're going to talk about what are the elements of it, as well as the benefits, and then we're going to kind of sum it all up at the end. So, owner priorities. So, personnel safety, no incidents. We have a lot of personnel working in very sophisticated plants. They are huge. And a lot of times they have a lot of nasty surfaces, as Tom put it. They can be very hot. You can have chemical product. You can have hot chemical product. You've got mechanical, rotating equipment, things like that going on. There's lots of places a person can get hurt if they're not properly trained. So everybody wants to go home, and they want to go home safely. And then after that, trying to keep these in appropriate order is maximizing production. Where we're all here today because we have a boss and they have a priority that they're making something or they're trying to achieve something that has a value, and that's why we have value to them, and so we're just part of the chain. And then obviously, to maximize production, we don't want any leaks and failures. Leaks and failures are bad. They go back to the creating safety issues, creates disruptions in production, and what we find with really all equipment, let alone non-metallics, is when things are running steady, like your car. When you're on the interstate, if all you're driving is interstate driving, you'll get 150,000 miles out of your car. But if you're just stop and go every day, through traffic, you're going to have more maintenance on that car. You can be changing the brakes more. You can be changing the tires more. Your plants are the same way. They like to run steady. So, and key here is we want to minimize downtime. Plants are wanting to run longer. Maintenance outages used to be every 6 months, every 12 months. Now pretty regular, 24 months. People want to run before they have to come down and do major maintenance. Now there's discussions, and we're seeing some plants going to 36 months, trying to stretch it out even further. Well, that puts more pressure on your reliability team to keep things up and running well. And obviously, to minimize lost production. At the end of the day, we're going to be talking a lot about materials here. We're going to be talking about appropriate steps for design, inspection, and so on. But at the end of the day, when you look at most of the plants that you work in, that you design, these plants are making hundreds of thousands of dollars, or even up to $1 million of product a day. So if that plant goes down for a single day, you just bought whatever for a year. I mean, if for $1 million you can do a whole lot of engineering and inspections. So it really pays to make good choices with respect to that. And particularly these days, unplanned outages, aren't tolerated. Nobody likes surprises. Nobody wants to be called in the middle of the night to say, hey, I want your team here at 6 a.m. because, we have a failure and the plant's down. Usually that's coming from the plant manager. So, owner concerns. So, what's the condition of my pipe? Pipe, you can't stick your head in there, so, is it okay? Should I be worried? When do I need to start to worry? When do I need to replace it? Do I need to worry about replacing it all? Am I just good? Looks good from the outside. And then, what we're hearing more and more, and it's all about that runtime and reliability is, they're like, okay, well, we got this outage coming up next year, but we also got 3 other things planned that we want to change out, that we're upgrading, or maybe we're replacing equipment. And I'd rather not throw this on top of all that because the budget's already stretched. So kind of go 2 more years and push it to the following outage. Well, if you're an owner, you need to make that based on informed decisions, not just, yeah, it looks good from the outside. You need to really know what it's, what condition it's in, because you don't want to go and get 6 months down the road and have a failure, and all of a sudden the unit comes down and you're down for a week, and somebody's going to answer for that. Well, you told me it was good. That's not really a good position to be in. The thing about it is we're so much dealing with the immediate fire, what is right in front of us, the call that we get. I come to the office on most days, and I've got something in my head. I got an agenda set up. Okay, I want to achieve these 3 things today. And 20 minutes in, somebody comes to my office and said, I got a call and such and such happened here. We need to get on a conference call in an hour. And then just the whole day goes to pot. Then all of a sudden, all of your priorities have changed, your attention has changed, and my 3 goals just went out the door. If I get the number 1 on my list, I'm happy at that point. And a lot of times I go home and I'm like, I did not get nothing done today. But that's kind of the way life is these days, So my point here is, it's a process, and it's something that you can't. Just like what we were just talking about, you can't just be reactive. Now you have to kind of start thinking ahead. So here's some of the unique challenges that when it comes to the FRP is, so FRP is a composite material. So here's basically a look at the filament winding process. So we've got basically a resin going on. These strands are being wetted out. They're being going around the mandrel here. And one of the unique things, if we're making a pipe from steel, they're making steel at the mill, so it's going through the foundry and all that. They're putting all the parts of chromium and molybdenum and all these different things in there to make steel, to make grade 853 or whatever they want to, and you're getting it out in billets or something else, and then they're taking that, moving that down, and they're making sheets, they're making pipe, whatever. That's a whole different process. When we make a tank, you're making flat sheets, and then they're going to bend it in to a tank, and they're going to weld it up. And the thing about with FRP, the properties don't come together until from right at the beginning. You're working from scratch, and the glass and the resin, everything's coming together, and you're shaping the pipe all in the same shot. Where when you're doing metals, you're developing those properties in advance in basically the raw bulk materials, and then you're taking that on, and then you're making whatever product, whatever component you want after that. So that's kind of the unique thing about fiberglass is, and it's all about the directions of the fibers. You hear about glass content, how many fibers per square inch you have in that laminate, how many layers are in it, glass to resin content, all those things. It's kind of what bears on the material properties. And here's, kind of, I was looking for the pointer. Here we go. So here's a pretty good photo that we have. So this is your corrosion barrier here. This is your resin-rich layer for your chemical protection. You can see all the windings here. That's your structural layer. So that's what we're developing all in one shot as we're developing properties. So you really don't know what the properties are going to be until the product's done. You can kind of predict it, but until you actually build it and you test it, you're never quite sure. So similarly, here's dual laminate. It's a unique thing about the dual laminate is basically it's built from the inside out also. So like here, you see, I think this is probably maybe CPVC. So basically, they're building, this is, you know, what we call a crossover, and so they're building the whole part out of the thermoplastic, and now they're going to armor it. You've heard that term a couple of times now. On top of, so the FRP will go on top, but after they build the lining segments together, so all these are put together, they're welded together. These are actually carbon targets that you see here, so we can do quality testing later. And this is what a head looks like over here. So you have the same thing. You have the interior is your thermoplastic lining, and you see how these are ground out, so we can expose that lining. And now we're of course basically stabbing the nozzles in. We're going to weld that usually from the inside and outside, and then we're going to fill in and reinforce those nozzles. So it's a very involved process. So when it comes to piping, so here's an example of I think this was about 20-inch HDPE in a chemical process plant. Very quickly, what you see is supports are very close together. Probably something like maybe 6 to 8 foot spans. I would bet one, you know, a fairly large diameter pipe. Here you have fusion joints, so that's unique to HDPE, fairly typical. Over here, I think this is probably PVC, I want to say. So here you see basically the solvent cement socket joints here that you see. There's a little bit of FRP there. Again, socket adhesive joints there. So a lot of different joint systems, different material properties, different strengths, and so they all have to be treated a little bit different. So what is a maintenance assessment program? So it's a risk-based condition assessment program to identify risks to personnel safety and operations of the plant. The purpose of the maintenance assessment program is to identify these risks, allow the plant to timely manage the risk to eliminate unnecessary hazards to personnel and interruptions to operations. So that's the goal is you want to maintain your safety, and you have an important task to do, but you want to do it in a safe way, and you want to be able to do it in a consistent way. And it doesn't happen by accident. So here's a large diameter tank. I want to say this was about 35-foot diameter. What kind of condition do you think that's in? You have any idea at all? This was actually in Chile. But yeah, it's got insulation totally wrapped on it. Probably couldn't tell you, I can tell you what material, but you couldn't tell from the outside what the material was, and let alone what kind of condition it's in. I can tell you that this tank was in service for 3 to 4 years when I saw it. So this is the foundation of that tank, and I'll point out a couple things. So typical large diameter tank frequently will be concrete foundation, and they'll basically have made grooves in the foundation. They're kind of little telltales. So if there is a leak in the bottom, you'll see something leaking out. Sure enough, we did, and this pretty blue stuff here is sulfuric acid. So, but what you see here, basically, it was going into the foundation, and you see it going all the way through the foundation, breaking down the foundation. This happened to be a stainless steel, 316 stainless steel tank. Should be good for that, but found out the welds broke down. The rest of the system went into lots of different non-metallics. But this is my point is, you get this, and now your foundation is basically trash. You find out that your tank's not so good either, and really until it's too late is the first time that you see it. This is an inspection that I did, I don't know, it's probably almost 20 years ago, I want to say. So did an internal inspection of the tank, looked up in the tank, and Basically, you can see daylight through the tank, not just seeing light. This is basically stiffeners here. You can kind of see a gooseneck there. There's the shadow of it. There's your vent. But literally, they had holes in the roof and didn't even know it. And people were going up on some of the other tanks that I was around while I was there. And when I saw that, I'm like, you probably need to keep your personnel off your tanks going forward, because we found others just like this. But until it's basically, it's drained, it's vented, it's cleaned out where you can go inside and take a look. You're not going to necessarily know that because it's all painted on the outside, or in this case, it was basically fiber bloomed on the top, and it kind of all looks the same. So here's some piping examples here. So this is probably a chlor-alkali plant, because I see this is probably all chlorine piping here. But again, you can't stick your head inside a pipe to know what the condition is. Generally, most of our piping inspections, when it comes to this, we're doing with a bore scope these days. We find that's the most reliable, we can get the best information, and gives us the best idea of what the existing condition is. So here's a couple more. So these, we can get inside of these, we open them up. This is a 29-foot diameter duct in a coal-fired power plant, so real easy to walk down that and see what it is. Looks pretty good. This here was a caustic line, dual laminate. This condition here is, I think, occurred after about 8 years, I want to say. This was polyproline dual laminate. You see that basically you've got ridges around the joint here. This continue to crack up here. This is a flange face. So here is your basically your joint that joins where the lining joins the flange face here. And actually you have this crack on the exterior that's basically from the excessive torquing on the dual laminate line, so it compressed the line to a point to where you started to produce this crack. So again, getting inside, but this wasn't found until after it failed and they took that spool out of service. So I've told you a little bit about kind of why we need it. In Florida, for example, the state requires every plant that has above ground storage tank to inspect them every 5 years. So they got to get a report and deliver it to the state. It doesn't say we have to go inside. So they get Joe, whoever inspector, probably a metal inspector, he walks around the tank, takes some pictures, makes some notes, sends in a report, never looks inside. And that satisfies the state. But if you're the owner, you have no idea what you have. I was on this site. It happened to be the same site as the one that shows you with the holes in the roof. And there's this big white streak going up the wall here. This is basically what you would call stress whitening. So it means that shell's overstressed at that point, and it wants to basically rip straight up the side. Lots of design issues with that I don't need to go into, but you also know there's no lugs, there's no hold downs on this tank at all. It's just sitting on a pad. So there was lots of design deficiencies in that, but tanks get repurposed, they get moved from one site to the next. You don't necessarily know the history, you don't know what service it came out of. Lots and lots of different things can happen. And so again, these things create unplanned outages, lost times, safety hazards, environmental incidents. We've been involved with failures where they've lost 30,000 gallons of HCl onto the ground. That's a serious incident. I guarantee you the EPA, OSHA, everybody was on site for that. It's undesirable. Anything over 5 gallons is reportable, so it's required to be reported. So it's, you know, a big deal. And again, you know, the main purpose is, you know, you're producing a product to go out to somebody else. So, you know, that's creating issues as well. So the point of all this is you need to get ahead of it. You need to make a plan. A lot of owners know what to do with their steel products. You know, we want to do that with FRP too, because, you know, if something needs repairs, you want to know it and you want to identify so it doesn't get down to the point you can address it in your time, so that you can keep things up and running without incident. And you know, if you've got to replace something eventually, you want to know a couple years down the line so you can get it into the budget and you can make plans and start to you know, work it within outage schedules also. So now we're going to kind of move on to elements of a maintenance assessment program. So simple stuff, you know, equipment ID, tank number, things like that, caustic scrubber, you know, those sort of things. You know, it could be, you know, recycled circulation tank, something like that. Who manufactured it? It's interesting. Went backwards. Description of the tank. You know, what's the diameter of the tank? How tall is the tank? That sort of thing. When was it installed? I mean, installation date is an important number because we want to know when it was installed, how new is it, how long has it been in service? Because if we walk, you know, up to a tank, we have no idea when it was originally installed. So we want to know, okay, if it was installed 3 years ago, right off the bat, we feel pretty good about it. If it says, you know, I've walked on site and seen an ACL tank, and it was installed in, you know, like 1978 or something like that, and I'm like, what the hell is this still doing here for? You know, so sometimes it surprises you, but you know, that's important information. You know, and then, you know, contents and chemistry. You know, what's the fluids in it? What's the concentration of the contents? Are there, you know, multiple chemicals involved? Do we know anything about it? Is there trace elements or something like that? A lot of chemistries aren't perfectly clean. If you're making, you know, intermediates, then it's generally going to be pretty clean. But if it's something that's a byproduct of the process, then there can be all kinds of stuff in there that makes quite the witch's brew. You know, is it liquid or gas? You know, chemicals, concentration. And then we want to get into materials of construction. You know, we want to know, you know, not just is it FRP, but what's the resin? What's the, you know, specific brand? You know, Duracane is a pretty common product that we see out there. And I'm not here to promote anybody, but most people are familiar with it. So is it 411? Is it 470? Is it 510N because it needs to be fire retardant? We talked about that earlier. You know, we want to identify what it is because it gives us an idea when we go back and look at it 10 years later. You know, is that the best resin for that service? You know, what's the expected life of that resin in that service? All these things you can kind of gives you information to be able to make good choices. You know, if it's a dual laminate, what's the lining material? What's the corrosion barrier thickness? All these things we want to document in our maintenance assessment program. You know, from a structural standpoint, is it filament wound? Is it hand layup? Because the thickness of the structure is not the same. From a design standpoint, if it's been filament wound, it'll be a little bit thinner than if it's hand layup, which has more resin in it, so the glass gives it the strength. So we would expect a hand layup tank to be a little bit thicker than a filament wound tank. So if we go and do UT on it, we expect to see that kind of difference. So other things, operating conditions. So, you know, what are the operating pressures? You know, is the sea vacuum? You know, typical, you know, temperature. Are there excursions? Those sort of things. Any kind of upset conditions, whether that might be it pulls a vacuum, it can temperature spike up to this. You know, we want to identify all those things in our maintenance assessment program. And then as we go along, whether it's from the initial fabrication to an in-plant assessment, we want to basically have the inspection reports. We want to have all of them in there. We want to have links to all of them in there so that we can go back and see the history. We can see when, okay, well, I remember this happened, but when was that? So let's go back and find that. So we want to have them all basically organized to where we can do quick research. You know, what's the current status? You know, what were the issues? When was this repair done? You know, we want to basically have access to all that because that's how we're going to make choices. Because what we want to do is basically we want to be able to develop a tracking system where we're following it along because everything is a trend and. It's not exactly, so we want to basically develop a timeline so that we can make choices. So again, what's the current condition? You know, there are things that we see that we say we want to monitor them, but we don't necessarily need to fix anything right now. But let's keep an eye on it so that we, when it's time, if something changes, that we can repair it, we can replace it. You know. And always we want to have that kind of running projection of life. That's what the plants want to know most. How long is it going to last? So this helps you basically develop that. And then again, planning notes along the line. You know, when was the last inspection done? Okay, we need to plan to reline this in the next outage maybe. And maybe we need to replace this and get into next year's budget. Those sort of things all go into your maintenance assessment program. And then kind of notes of basically next to do's. So this is kind of what it looks like real quick. To kind of give you an example. So this is kind of the data that we talked about. I don't know how well you can read this. This is basically just for one tank. So here, example, chlorine dryer and the manufacturer, drawing numbers, diameter, height, installation date, contents, wet chlorine gas, and sulfuric acid. Structure was Duracane 411, Corzan CPVC. Then you got a structural thickness here, design conditions here. Here's my links for my shop report, my inspection reports. And then again, projected remaining life. I know my next outage is this year actually. So that's kind of, and then you can put down additional notes down here. That's kind of generally what you want to see in a maintenance assessment plan. So real quick, the benefits, you need to know the risk. We're handling hazardous chemicals a lot of times. So you want to know when do I need to worry and when am I good and I can go pay attention to something else. And you don't want any surprises. The last thing you can do is think that, oh, well, that all looks good on the outside, and then you get a call, we'll walk in first thing in the morning, and you hear that, well, this flange failed, or, this tank bottom's got a crack in it. And obviously, the whole point is to have that kind of advanced planning, and in the end, if you're working in the plants, you want to make informed decisions. So this is a means to basically organize the data to where it's at hand, so you can make good choices as you go forward. So basically, kind of what we're kind of talking about the maintenance assessment side. So this is basically the general recipe of, okay, how do we run well? Is we want to have good specs, we want to qualify our vendors, we want to do good engineering, check our calcs, we want to have inspection in the shop and then in process as well. And what we find is ragged gap is getting talked about a lot more. Plant owners are having a lot more expectations put on them to run well and answer for everything that they do. Here's my buddy Tom here. Inspection. Yeah, they're there. So again, the goal here is to manage service life, operating conditions. If conditions change, you need reassessment. There's also an opportunity to do material sampling. We have non-destructive testing, like UT, for example, We also can do destructive testing. We can take core samples, we can take a sample of pipe, pull it out of service, put a new spool in, and then go back and test it. And you know, the big important point here is the documentation and tracking part. So this is something that we're starting to do with all of our customers. We're starting to take all our inspection reports and starting to build this for our customers now, because everybody is shorthanded. Everybody is stretched for what they have to do day to day. So we're trying to help out for that. So now we're going through all our documents now and starting to put that together for all of our clients. And you know, again, in the end, basically it's about maintaining reliability, maintaining safety on the plant sites, and you want to get the most out of your equipment. So the more information you have to do that, the better. And that's really all I have. Any questions, Chris?
Yeah, so the map example you had was a spreadsheet that had like the vessel size. Do you guys also recommend kind of an assessment of like the piping or pipe sports in general? Do you have like an assessment plan for that as well?
It would work the same.
Similar.
So you'd be defining the services, design conditions, sizes, when it was installed. You would track it just the same. You know, a lot of times we'll do external walkdowns, looking at supports and things like that, looking for, you know, evident, you know, excessive movement, things like that. But then, you know, it's borescope. It's, you know, taking a sample out of service and doing testing on it. We can do permeation testing. We can look at wear and things like that as well. But yeah, I mean, piping is the hardest. You can walk into a tank or jump through a manway, but piping, yeah, you need to take a closer look at it. So you have to be a little bit more plain that way.
And is there any like frequency? I know it's probably specific on the different services and kind of the equipment and layout, but I don't know if there's a recommended frequency for these inspections you recommend.
Well, that's part of the risk assessment. Is you have to evaluate what the services are. You know, how severe a service is. Is a chemical service? Is it a service where you can see a lot of wear and erosion, like a slurry service, for example? You know, the more mild service it is, you can stretch them out. Maybe it's every 5 to 8 years, something like that. If it's, you know, something that's more hazardous, more, you know, corrosive, you're probably looking at every 2 or 3 years. And again, brand new, you're not going to look at it as frequently until it, you know, as you get further down the life of it, you're going to be looking at it more.
For a typical internal inspection, you mentioned like UT. Do you also do like barcode testing? And I guess what other non-destructive testing equipment and options?
So that's like an on-site test. So UT, we're doing that if you have substantial loss of material. A lot of FRP services, the thickness is relatively unchanged. UT doesn't tell you a whole lot. And because where tanks fail, for example, and even piping, it's not in the shells, it's in the joints, it's in the bottom. You know, it's in the T connections. That's everywhere you have a human hand touching is the first place, the highest potential place for something to fail. And UT is not going to help you there. You really need to get inside and look at that.
And then I guess, is there...
But the hardness is a part. I want to make sure I answer your question. So yeah, we're checking Arco harnesses all the time, inside and outside.
I don't know which company it is, but there's some technologies out there where they can insert like a really fine, almost needle sort of thing into the structure. Like, do you guys do any of that sort of, or know about that?
I'm aware of that. I've seen that used in pulp and paper. Basically what they do is they drill a hole through the structure and they put a fiber in there and they kind of backfill it with epoxy so it's kind of bonded in there. So that when the corrosion barrier wears away or attacks, then basically it's like I guess a conductive filament, and it'll tell you, basically it'll start conducting when you're getting through it. But you have to monitor all that, so you have to basically you have to take that all back to a control center or something where you can monitor that regularly, and pretty much you're drilling a hole in a pretty good tank when you're doing those sort of things. Generally, yeah, we don't really recommend that. It's a dual laminate tank, that's not even really reasonable. There's some places where you have tremendous wear, that might make sense, but in chemical service, really, it's generally not a good thing to do.
I'm sorry, I'm gonna add another question on here. Let's say we go into a tank and there's some previous repair work done, but we suspect when that previous repair was done, it's gone through the wear was through the corrosion barrier. Is there a way to, I guess, inspect and see how much wicking has there been? Or like when you're walking into an existing tank, how are you able to sniff out those kind of areas?
Well, I probably Tom could talk a lot better to this, but so generally when we go and do an internal inspection, one of the first things, the simplest things we can do is barcode hardness. So as long as, and generally that number starts at around 30, 35 is a typical barcode number for something new. So that number's gonna diminish over time because the insides are gonna get softer. And so as long as we're getting numbers, we're good. If we're getting 0 or we're seeing 5 or 3 or something like that, it's a problem, and likely your corrosion barrier is almost gone. If you're starting to see the print of the structure underneath there substantially, you're getting really close to the structure. At that point, you probably need to look at relining or maybe replacing it depending on what the diameter of it is. So as long as you're getting a bark haul, generally you're serviceable, but then you have to start to decide, okay, when do I want to do something?
But there's ways to do structural testing to measure permeation into the structural wall. If you take core sample from that and
And generally, if there was a repair, they should be taking it down to where there's no chemical contamination in that surface. You don't want to be bonding to a contaminated surface because the bond's not going to go well. It's not going to stay. It's not going to be permanent, or at least as permanent as you can. So that's why Tom always picks on me. I got a putty knife I keep in my backpack, and I'm going right up to that joint, and I'm trying to see if I can't jam it up in there. If it's a good joint, I won't be able to do that. But if it's a bad joint, I'll be able to do that, and I'll be able to pry it up. And you know, it's aggressive, but like I say, good work you cannot, you can't hurt it with a putty knife.